Hi everyone, this video is on exercise 9F of A-Level Maths Pure 2. So in the last video, this is question 2, and I went through parts A to D, and in this video I'm going to do F and H because these are the most interesting ones. E and G are very similar to the previous 4 questions that I solved. Okay, now for question F, we have the function y is equal to sec squared x over x, and we want to differentiate this. So this one is an interesting one because we are going to use 3 different techniques, or maybe 2 techniques, let's say, because we need to use the quotient rule. We have a fraction. We need to use the chain rule because in the numerator we have sec squared x, so that's of the form a function and then some power. And also the last one, which is the third component, is just using a standard result from trigonometric functions. So yeah, that's not directly a differentiation method, but it's just something that is very useful. Okay, let's see how can we use these techniques. So first of all, as usual, the denominator is going to be squared. The function in the denominator is going to be squared in the quotient rule. Then we start by writing down the first function, the denominator function, times the derivative of the numerator function. So let's talk about the numerator function before we continue this question. So let's say the numerator function is g of x is sec squared x, and it's a chain rule because this is the same as writing sec x and then a squared outside. So if we want to differentiate this, 2 is the power, so it comes down. And then, as always, we differentiate the inside function. So sec x differentiates to, as I wrote here, just to see what we had. Basically, when we have sec kx, that differentiates to k sec kx times tan kx. So in this case, k is 1, so it's just going to be sec x times tan x. So yeah, in this case, 2 times sec x times tan x. Also, don't forget that when you use the chain rule, the first part of chain rule is basically using the power and differentiating inside, and the second part is just writing basically the inside function without any changes and just taking away 1 from the power, which is obviously sec x. So we have 2 sec x times tan x times another sec x, which is going to give us 2 times sec squared x, because we have 2 sec x's, times tan x. So this is the first part of using the quotient rule. The second part is easier in this question because the second part is the derivative of the denominator function times the numerator function. So the derivative of x is just 1, so it's minus 1 times sec squared x. And we can simplify this. We can factorize this, but it's not necessary, so I will just leave the answer in this form. Okay, question H. We have y is equal to cot squared 2x minus 1. So in this one, we need to use the chain rule and some of the standard results from trigonometric functions. So again, it's a chain rule, so we can rewrite in this form just to help us because it's kind of a nicer form. So yeah, the power comes down. That's the first step. Then as a second step, this time I'm just going to write down the inner function basically inside the bracket, and always the power is going to be 2 minus 1 when we write down whatever is inside the bracket. In this case, 2 minus 1 is just 1, so that doesn't change. Now the second part of the chain rule is about differentiating inside. So differentiate the function that is inside. And if you want to differentiate cot 2x minus 1, again, just to remind you, whenever we have cot kx, that differentiates to minus k cosec squared kx. So in this case, we have cot 2x minus 1. So this is the part that is inside the cot. So this itself differentiates to 2, because 2x minus 1 just differentiates to 2. And now the cot part, that differentiates to minus cosec squared inside the bracket. So minus cosec squared 2x minus 1. So just one more time, we have a chain rule. So we first start by differentiating, basically by writing down the power. That's the first step. And then we just write down the function inside the bracket with obviously the power minus 1, since it's 2 minus 1 is 1. So we get cot 2x minus 1. And the second part is, differentiating the function that is inside the bracket. So if you want to differentiate cot 2x minus 1, this is one of those standard results. I use the standard result method. You can also directly do this, which I will show in another video. So yeah, cot, first of all, you differentiate what is basically inside. So you have cot of 2x minus 1. So 2x minus 1 differentiates to 2. That's where this 2 came from. And finally, cot something differentiates to minus cosec squared something. So that's how we got each of these parts, and we can simplify this to make it look slightly nicer, which is going to be 2 times 2 and then times minus is minus 4 times cot 2x minus 1 times cosec squared 2x minus 1. And yeah, that's it for this video. Thank you for watching.